Negative exponents, well, that's kind of weird. So one way I like to talk about negative exponents is to first build a table with positive ones. 2 to the first, well, that's 2. 2 squared, well, that's 4. 2 cubed, well, that's 8. And usually when we think about exponents, it's going this direction. How would I go from 2 to 4? Well, that's just times 2. How would I go from 4 to 8? Well, that's just times 2. But you can also think about exponents the other way. If I want to go from 8 to 4, I could divide by 2. To go from 4 to 2, well, that's division by 2. So I could use this to build up this idea of 2 to the 0 power. Well, 2 divided by 2 is 1. 2 to the 0 power is 1. And in fact, anything to the 0 power is 1. Sometimes that's one that people struggle with. When you use this divide by 2 idea to get there, it makes a bit more sense because now it follows the pattern. So what about negative exponents? Well, 1 divided by 2, that's 1/2. And I could keep going. 2 to the negative 2, well, that's just dividing 1/2 by half. Half of a half is a quarter. If I do that one more time, 2 to the negative 3rd power, well, half of a quarter is an eighth. So we can use this idea of repeated division to get these negative exponents. What you'll note if you make this table is that you'll see a lot of repeats. 2 to the negative 3rd, well, I've got the same denominator as 2 to the positive 3rd. 2 to the negative half, that 4 in the denominator, oh look, that's the same as 2 squared, the positive exponent 2, which is just a 4. So frequently we use the word reciprocal to describe this. A reciprocal is just a flipped fraction. The reciprocal of 2, oh, that's just 1/2, and so on. The reciprocal of 4 is 1/4. The reciprocal of 8 is 1/8. So when we're talking about using this idea of substitution in order to get the same base, when you see something like this 1/7, well, that's the same thing. I'm just going to rewrite the left-hand side here. That's the same thing as 7 to the negative 1 power. If this would have been a 1/49th, that would be the same as 7 to the negative 2 power, and so on. Of course, they didn't ask us the 149, so we don't actually need that. But it's important to be able to work with those fractions and use those negative exponents. Well, this is just common base problem. So 1-to-1 property here, 4x plus 11 will equal -1. And the algebra here is really not that bad. I already have all my variables on the left, so let's just subtract the 11 from both sides. That will leave me with 4x is -12. And dividing both sides by 4 will get me a -3. Let's jump way over to the other side, look at a slightly more difficult example. Once again, we do see that 1/3, and we also have an 81. So those are not common bases, but we can get common bases. So I'm actually going to start by looking at that 1/3. We know that 1/3 is the same thing as 3 to the negative 1 power. So let's see if there's a way to help us out here in this wonderful table. You know, I really would like for both of those to have a base of 3. Oh, look. 81 is the same thing as 3 to the 4th power. So I can substitute 3 to the 4th power in for 81. Keep in mind there will be a power to a power property on both of these. On the left-hand side, we had that 2x plus 5. On the right-hand side, we had that 2x. And to keep my colors consistent, that red equals just looks really nice in there. So we've seen quite a few power to a power problems at this point. What we need to do is multiply the inside power by the outside power. So we'll wind up with a 4 times 2x plus 5 on the left, and a -1 times 2x on the right. So the algebra here is not too bad. The trick is really knowing what to do with that fraction. In this case, We just substitute that for a 3 to the negative 1. Keep in mind, if that had been a 1/9, we could substitute 3 to the negative half. If it had been a 1 over 81, for example, we could substitute 3 to the negative 4, and so on. Again, they didn't ask us to find those fractions, so we don't need those for this problem, but it's important to be comfortable with the idea. Distributive property on the left, 4 times 2 is 8, 4 times 5 is 20. On the right, the opposite of 2x is just negative 2x. And this is a pick on the little guy problem. So I can add 2x to both sides. That will get rid of all my x's from the right. I can bring my constants over to the left. And that will leave me with 10x equals negative 20. Well, I don't want 10x, I just want 1x. Let's divide in blue. Dividing both sides by 10, we'll get x by itself. Negative 20 divided by 10, well, that's just a negative 2. That is the ugliest equal sign I have ever made. And that is how we can deal with those reciprocals. Let me know if you have any questions here. There are a few practice problems along with a couple spiral review problems in this packet for you to work through this, this idea. Let me know what you need, and I'll see you next time for some applications.